Hello everybody, welcome back, and we are heading into final lessons of piston engine, and I hope you guys enjoyed the previous video. And here is let's discuss mixture strength, and along with this I'll also discuss grade of fuels. Okay, so this video as well will have a couple of couple of concepts mixed together. It's fairly very easy, this lesson as well. This is just theoretical basic stuff. I'm just gonna write down points and you're just gonna note it down, that's all. There's not much to explain, but I'll try my best again. So let's start off with the mixture strength. So what is mixture strength? It is the air to fuel ratio by weight. That's all you have to know. What is mixture strength? It is the air to fuel ratio by weight, and it is fed to the carburetor and further on. Alright, so there's something called as chemically correct or stoichiometric mixture, which is chemically correct, and this is air is to fuel is 15:1 by weight again. Okay, so that is the problem with chemically correct this thing is it burns faster than a rich or a lean mixture. It is chemically correct, so this chemically correct mixture burns faster than rich or lean mixture. So it is not very desirable, because if it burns really fast, it's not really helpful. So because that can cause detonation in the engine. So I just write it down, can cause detonation. Therefore what we do is we have a mixture that is which we practically use is 15% richer. Richer here means there is more fuel in the mixture. Alright, richer. If it is, the word is leaner, less fuel is used. So this is around about 15 is to 1.15, or if you want to convert it into direct terms, it is 14 is to 1. So 14 parts of air with 1 part of fuel. So it is basically more fuel. What happens with this is cooling is better due to evaporation of fuel, okay, which gives better power. Alright, so this is what we practically use. Now if mixture temperature is too high, what we do is there's some compound called water methanol, methanol is injected into induction manifold to cool the mixture, and bottom line we do is we prevent detonation. Alright, detonation. Now what is detonation? Let's discuss briefly, and I'll give you the causes and reasons why detonation occurs, symptoms of detonation as well. So detonation, first up we'll discuss causes of detonation. Causes will be too lean mixture, if you have high compression ratio, okay, too high ignition advance, overheating overheating of the engine itself. This can happen due to very sharp rate of climb. If you are a low power aircraft and you are climbing rapidly at say 6,000 7,000 feet per minute, the engine is going to overheat, and that's going to cause you detonation. Excessive spark, excessive supercharging. We'll discuss supercharging coming up soon. And if you use different grades of fuel mixed, basically if you don't have the right fuel in your fuel system, so that's also going to cause detonation. What are the symptoms of detonation? How do you recognize symptoms of detonation? How do you recognize a CHT is high, it is increasing the cylinder head temperature, because you have a gauge. If you remember, I told you in the previous video, couple of videos back. B, there's a bang, explosive noise. C, vibrations, engine is vibrating heavily, you are feeling it. D, gray smoke, puff of gray smoke at the exhaust. E, sudden increase in RPM. E, D, E, F, maybe you can also you can have a fluctuating manifold pressure. Okay, so these are the symptoms. How do you, if you're sitting inside the cockpit, how do you know if your engine is showing signs of detonation? How do you get rid of it? Or remedies for detonation. So simple, ridge the mixture. First action, simple as that. Ridge the mixture. Open cowl flaps to reduce your overheating in case it's the engine is struggling, right? So you cool it down faster. And descend fast. If you were climbing really fast, it's gonna cause detonation, so you have to descend. And in case even at straighten level, if you're showing signs of detonation, you're gonna do a steep descent so that the engine cools down and everything falls in place. Alright, so let's discuss the next topic, that is grade of fuels. Grade of fuels. Okay, so grade of fuels in aviation industry, the fuel is graded based on something called an octane number. Okay, so what does this octane number signify? So if your octane number is high, that means your compression ratio is high. Simple. Now what compression ratio gives is, if you have a high, what is compression ratio? If compression ratio is where your fuel would not detonate even on high compression. Do you understand? It's simple, right? If you have high octane number, you have a high compression ratio, so your fuel will not detonate easily. Okay, so it looks like, yes, it's obviously desirable, right? So a high performance aircraft use higher octane number fuel. Alright, so that's how you grade fuels in aviation, avgas and everything. There are different types of fuels. You have 80 by 87, 100 LL, 100L, 100 HL, 130, 140, there are n number, and the list just goes on. So we'll discuss what we need to. Then there's a concept called torching. I think I discussed this in a piston engine video as well. It is burning of mixture in exhaust pipe. Okay, burning of mixture in exhaust pipe. So now this is due to exhaust valve is faulty or sticky, and it is also caused by prolonged rich mixture. If you're using rich mixture for quite a lot of time, your exhaust pipe will torch, because there's too much fuel inside, and if your valve is already sticky or faulty, then the fuel going to go in exhaust pump and it's going to burn. Okay, Then there's something called as backfiring. Now this is opposite, and it is due to prolonged lean mixture. If you're on quite some time on a lean mixture, it's going to cause you backfiring, and it's also due to pre-ignition. So this is generally because of inlet valve sticky or faulty. So backfiring, actually the fuel kind of burns into the in the induction manifold. So that is backfiring. Alright, now we'll discuss colors of fuel. The basic aviation that general aviation we fly, if you fly the Cessnas and everyone, that has 100 LL, 100L or 100 LL, that is blue in color. Okay, then you have different. I just picked up a few just to have a difference. There's 100 HL, that is green. There is 130, that is green as well. Then there is what we have 140, that is pink. So the list just basically goes on. And then there is there's also one more blue that is there, is 100 by 130. This is as well is blue. And the jet kerosene that the commercial aircraft and all, jet kerosene, basically the jet kerosene is clear straw color. This has by the way, this jet kerosene has high specific gravity. Alright, so now I will want to bring some effect on CHT and EGT on mixture ratio. Effect on depending on the mixture ratio. If you depends on mixture ratio, if your what happens to your CGT. So suppose you have 8:1. Okay, so this is 8:1 is, if you by now if you recollect, it is a rich mixture. So this is generally used at idle or takeoff, right? So in this what happens is your CHT is low, EGT is also low. Then let's go to 12:1. Okay, this is a normal setting for piston engines. In this case it is CHT is also low, EGT is low as well. Okay, then there's something called as 15:1, which is, if you remember, it is chemically correct mixture. Chemically correct. So if you remember, it burns really fast, right? So CHT is high, your EGT is also high. Okay, then there is 18:1 during economy. Basically this is I'm talking about cruise. Okay, so cruise, what happens, your CHT is maintained but it is high as well, since the mixture is little lean, though the gas temperature is maintained low. Yeah, EGT, the exhaust gas temperature, because you are at a higher altitude. Alright, so that's about this thing. Now I would just like to we'll just have a quick short discussion. It's not much to explain. What happens during when you try to start an engine. So I don't think there's need to write down, basically. So when you start a cold engine, alright, so when you start a cold engine, the fuel will burn only if it is vaporized. The fuel is not gonna burn in liquid form, or it will burn only when it is vaporized. But if the engine is cold and you try to vaporize it, only a small fraction of the fuel will vaporize. Therefore, to make sure there is sufficient fuel vapor in the cylinder, a rich mixture is required. Alright, so I hope you got that. So when you start, there's less vapor, hence to start the engine properly, we have a rich mixture start always, so that you have a lot of extra fuel to vaporize the mixture. Alright, and what else can we talk about? And yeah, I think that's all about it. Also, these rich mixture is used for to compensate for the exhaust gases that are locked in the combustion chamber due to a previous shutdown. So if you have a previous shutdown, so there will be some gases locked in the combustion chamber, exhaust gases I'm talking about. So just to compensate for that, a richer mixture is used for a start as well. The two reasons basically to give: one is vaporization and one is locking up of gases in the combustion chamber. Alright, then I think yes, that should be good enough. So we're done with grade of fuels and also mixture strength. So we will be doing the last part, and that is carburetors, and that is important as well. I'll see you next week, and I'll try to give a short summary for piston engines, summary and important points. That will be a longer video, of course. So alright, yes, that's all about it for today. If you like the video, please do share it, please like it, subscribe to the channel, of course. Like the page on Facebook. The links are below. There's a quiz link for each video that I'm making from now on, so please try the quiz. The quiz is free as well. My motive is always to make everything free for you guys. So take the quiz, assess yourself, what have you understood from this lesson here on this video, and that's all from me today. Take care guys, bye bye, have a great day.